Have you ever wondered how the chemistry of water impacts the health and well-being of fish in an aquarium? Well, the answer to this question is a resounding yes! The water in which fish live is more than just a place to swim. It's their lifeblood, their atmosphere, and their sustenance. Water chemistry is a critical factor that influences not only the health and vitality of fish, but also their behavior and their ability to reproduce. Imagine you're a fish. Your entire world is the water in your tank. You breathe it, you eat in it, even your body temperature is regulated by it. Now imagine if that water is of poor quality. Well, it's like having to breathe polluted air, eat contaminated food, and live in an environment that's either too hot or too cold. Not very pleasant, is it? That's why maintaining optimal water chemistry is paramount for the well-being of your aquatic friends. So, what are some of the key parameters of water chemistry that fish require for optimal health? The list is long, but let's touch on a few. The pH level, for instance, is a measure of how acidic or alkaline the water is. Different fish species have different pH preferences, with some thriving in more acidic conditions and others in more alkaline environments. Then there's water hardness, which refers to the concentration of certain minerals like calcium and magnesium in the water. Some fish prefer hard water, while others do well in softer water. Temperature is another key factor. Just as humans feel uncomfortable in extreme temperatures, fish too can suffer from stress and disease if the water temperature is not within their preferred range. And let's not forget about the nitrogen cycle. This is a natural process that occurs in the water and involves the conversion of harmful substances like ammonia and nitrite into less harmful ones like nitrate. An aquarium that is properly cycled will have a stable and healthy environment for the fish. Understanding the chemistry of water in your aquarium is the first step to ensuring a healthy environment for your fish. So tune in to the next part of this series, where we'll delve deeper into the concept of pH and its role in maintaining a suitable environment for different fish species. So what exactly is pH, and why is it so crucial in maintaining a suitable environment for different fish species? Well, pH is a measure of how acidic or alkaline a solution is. The scale ranges from 0 to 14. A pH of 7 is considered neutral. Anything below 7 is acidic, and anything above 7 is alkaline. But why does this matter for our aquatic friends? Different species of fish have evolved to thrive in different water conditions, including varying pH levels. This is largely due to the natural habitats from which they originate. For example, many Amazonian fish, like neon tetras and angelfish, are adapted to the acidic conditions of their native blackwater rivers, with a pH often falling between 5 and 6. On the other hand, fish like African cichlids, which hail from the alkaline waters of the East African Rift Valley lakes, prefer a higher pH, often between 8 and 9. Now you may wonder, can't fish adapt to different pH levels? While fish can tolerate slight fluctuations in pH, drastic or sudden changes can cause stress, leading to illness or even death. Therefore, it's essential to research the preferred pH range for your specific fish species and to monitor and maintain this level in your aquarium. But how do you do that? Well, there are several ways to measure pH, from simple test strips to high-tech digital meters. And adjusting pH can be as straightforward as adding specific products to either increase or decrease the pH to the desired level. However, remember this: stability is more important than achieving a perfect number. Rapid changes in pH can be far more harmful than a slightly off pH level. So, strive for stability first and foremost. And lastly, pH isn't the only parameter to consider when it comes to water chemistry. Other factors like temperature, hardness, and the presence of certain chemicals also play significant roles in your fish's health and well-being. Maintaining the right pH balance, then, is key to a thriving aquatic ecosystem. But pH isn't the only thing we need to keep an eye on. What other factors of water chemistry should we be thinking about? Well, let's dive into the depths of water hardness first. Now, water hardness refers to the level of certain minerals, primarily calcium and magnesium, present in your aquarium water. Some species, like the majestic African cichlids, thrive in harder water, while others, like the elegant neon tetras, prefer their water a bit softer. And let's not forget about the temperature. Each fish species has its own Goldilocks zone, a temperature range that's just right. For instance, tropical fish like guppies and bettas enjoy a warm 75 to 80 degrees Fahrenheit, while goldfish prefer cooler climes around 60 to 70 degrees. Next up is the nitrogen cycle, a critical process that ensures your aquarium isn't overrun with harmful waste. Fish produce ammonia, a toxic compound, as a byproduct of their metabolism. Bacteria in your aquarium convert this ammonia to nitrite, then to less harmful nitrate. This cycle is vital to maintaining a healthy environment for your finned friends. Speaking of bacteria, let's talk about filtration systems. These systems remove physical and soluble chemical waste products from your aquarium. Mechanical, biological, and chemical are the three main types of filtration. Mechanical filters trap solid waste, biological filters contain bacteria to break down waste, and chemical filters remove dissolved substances. And lastly, let's not forget about oxygen. Yes, fish breathe underwater, but they still need oxygen to survive. Aeration, the process of introducing air into water, is key to maintaining adequate oxygen levels. This can be achieved by using air stones or water movement from filters or waterfalls. So, as you can see, there's more to water chemistry than just pH. Now that we know what to look for, how do we go about maintaining these optimal conditions, you might ask? Well, the secret lies in regular water testing and careful observation. Testing your aquarium's water on a weekly basis is a vital practice. This helps you to keep tabs on the water chemistry and ensure it's within the appropriate parameters. There are numerous test kits available on the market, each designed to measure a specific element of water chemistry, from pH to ammonia, nitrate, nitrite, and even water hardness. But remember, testing alone isn't enough. You need to understand what these numbers mean. For instance, a sudden spike in ammonia or nitrite levels could indicate a problem with the nitrogen cycle, possibly due to overfeeding or a deceased fish. On the other hand, a sudden drop in pH could mean the water is becoming too acidic, which could stress or even harm your fish. So what do you do when you spot an imbalance? The first step is identifying the cause. Once you've done this, you can take the necessary steps to correct it. This might involve changing a proportion of the water, adjusting the temperature, adding a water conditioner, or even introducing live plants to help absorb excess nutrients. Speaking of live plants, they are one of the most effective natural methods for stabilizing water chemistry. They absorb harmful substances like ammonia and nitrite and release oxygen, providing a healthier environment for your fish. Plus, they add a touch of natural beauty to your aquarium. But don't forget, each species of fish has its own unique set of water chemistry requirements. If you have a community tank with different species, you'll need to aim for a balance that suits all inhabitants. It might be a bit of a balancing act, but with careful planning and regular testing, it's entirely achievable. In conclusion, maintaining optimal conditions in an aquarium is a continuous process. It requires attention, understanding, and a willingness to learn and adapt. But the payoff is worth it, as you get to watch your fish thrive in a healthy, balanced environment. Regular testing and observation are your best friends when it comes to maintaining a healthy aquarium. But there's more to it. What about saltwater aquariums, sensitive fish species, and introducing new fish? For saltwater aquariums, the water chemistry requirements can be quite different compared to freshwater setups. For instance, marine fish species require specific levels of salinity, magnesium, and calcium. These elements play a crucial role in maintaining their health and well-being. It's essential to monitor these parameters regularly to ensure they remain within the optimal range. Moving on to sensitive fish species, some fish are particularly sensitive to changes in water chemistry. They require stable conditions, and any significant fluctuation can lead to stress and health issues. Examples include discus and some species of South American dwarf cichlids. For these fish, regular testing of water parameters and prompt adjustments are vital to keep them in good health. Now let's talk about introducing new fish to an established aquarium. This process requires careful consideration. Before adding new fish, it's important to ensure that the water chemistry of the tank matches their specific requirements. A gradual introduction is recommended, allowing the fish to adjust to the new water conditions. This can help minimize stress and potential health issues. But what about the challenges of keeping incompatible species together? Well, this can be quite tricky. Different fish species have different water chemistry requirements. If these requirements clash, it may lead to an imbalance in the tank's environment. This is why researching the needs of each species and planning the community carefully is so important. It's also a good idea to have a backup plan in case certain fish species don't get along. In conclusion, maintaining the right water chemistry is a complex but vital part of fish keeping. It involves understanding the needs of different fish species, regular testing and adjustments, and careful planning of the community. Remember, the goal is to create a stable and healthy environment that replicates the natural habitats of the fish as closely as possible. With careful planning and attention to detail, you can create a healthy and harmonious environment for a diverse range of fish species.